Okay, this is your man Alan, and today we want to look at plane geometry 2, that is circle theorem. And in this video, I shall be teaching you the various principles and theories that consist of the circle theory. Now, I found a way of presenting this very clear for all of us to understand. So I decided to get a tripod stand, I decided to get a projector and a microphone that can help us. So these are some of the tools I'm using to do my recording. If you want to get them, I'll put the link in the description so you can go and buy them for yourself. You don't need to go and buy some heavy things. It's not just costly, at your own pace. Okay, so without much ado, let's get into it. So second theorem. Want to look at the theorems. One, there are a lot of theorems that consist in the second theorem. But look at the first theorem, which is talking about angles in a semicircle. We'll be talking about angles in a semicircle. Why do we need to learn about the theorems? Because in the whole circle theorems, or plane geometry 2, we are dealing with reasons and properties. So we don't do rigorous working there. We only apply the theorem to answer the questions. So every answer you give, you must be able to provide a reason. And that is more important reason why we have to get the meaning of this theorem. So the first theorem said that the angle in a semicircle is always 90 degrees. When so a semicircle, it means that it has a diameter. The diameter divides the circle into two equal parts. So any angle that is found inside that diameter or that semicircle to the circumference is always 90 degrees. This is what it means. So we have a circle and I have a diameter. So any circle, so the diameter here is AB, diameter AB. So any angle that is subtended from the line AB, and this is center, okay? So from here to here is a radius, and here to here is a radius. Two radius joining a straight line gives you a diameter, okay? So any angle formed here becomes 90 degrees once it is in this semicircle, so the same way to this one. So angle X here and angle Y here will always sum to give you this angle. So it's a very good property. Once you see it in the semicircle, you should know this is 90 degrees. But what to prove? We shall prove that in the meantime so that you get the understanding more. So if this side is C and this side is the O, which is the center O, we want to look at the meaning and the proving of it. But yet still, we are saying that the angle subtended by a diameter at the circumference of a circle is a right angle. And you can see that from the previous one. It's a right angle because it's forming an angle of 90 degrees. And an angle subtended by the diameter at the circumference is a right angle, which is the 90 degree here. Now, we just want to illustrate a lot of them for you to understand. So if I have a circle and I have a diameter, this angle subtended from the diameter here to the circumference is 90 degrees. So this angle is 90 degrees. I can also have another different circle and the diameter, no matter how the line is drawn, but once it's a diameter, it is dividing the circle into two equal parts. Okay? And if it's two equal parts, then the angle that is formed inside of the circle to the circumference is 90 degrees. Okay? So no matter how it is drawn, this angle is 90 degrees. If I got another circle like this, the diameter is also drawn and divide the thing into two equal parts. So this semicircle is another semicircle. Any angle that's obtained from this diameter to the circumference is giving you 90 degrees. Okay? Then the same way it's obtained from this angle to 90 degrees. So this is a principle. Now once you look at the circle theorem, or a question, and you realize that it's, the angle is subtending from the diameter, you should clearly know that that angle will give you what? 90 degrees. Now we get to look at question 1 using the first theorem. Line AB is the diameter of a circle. So here they have stated it for you to get clear. Sometimes it might not be a diameter, it may look like a diameter, but it is not a diameter. So unless maybe the question non specified, then you are free to go. Okay? And then angle CAB, the angle is on the A. Okay? CAB, the angle is on the A. It's 50 degrees. 50 degrees. Calculate angle X and Y. Angle X and Y. Now, you give reasons to your answers. Now, you see that this question is asking to give a reason. That is why we have to learn that particular theorem. Okay? So, angle X here, you quickly know that this is diameter. They said this is diameter. And angle subtending to the circumference from diameter is what? 90 degrees. So it means that X is 90 degrees. Angle in the semicircle, or angle subtended from the diameter to the circumference of the circle. Okay? The circumference is the distance around the circle. So anytime we mention circumference, you know what we are talking about. Now, I want to talk about the angle Y. So here it's 90 degrees. Now, angles in the triangle sum up to 180 degrees. That's the first theorem we just look at. With this angle plus this angle should also give you 90 degrees. Because if everything inside here should give you 180, then this angle plus angle is 90. So that 90 plus 90 gives you 180. So I can just take 90 minus 50, and I'll get y as 40. Or you sum 50 plus 90 plus y and equate it to 180, and you will get your. So 90 degree plus 50 degree will give you 140, and 140 from 180 will give you 40 degree. So it means that y here is 40 degree. 50 degree plus 90 degree plus the 40 degree, which is that, and then it must give you 180 degree. Angles in triangle sums up to 180 degree. So this angle Y is also 40 degree. You can pause the video and then look at it and try to understand it by yourself. You can also work it before you do it again for understanding. Question 2, still on the same theorem. Line XY is the diameter. Line XY is the diameter of a circle, right? What is the sum of angles A and B? Explain your answer. What is the sum of angles A and B? What is the sum of angles A and B? You see that? We know this angle to be what? 90 degrees. Yeah, and what's the sum of this? You quickly know that A plus B will give me this angle. Yes, 90 degrees. Then A and B must also be what? 90 degrees. So the sum is 90 degrees. So angle C, this unmarked angle is 90 degrees. That is as it is an angle in a semicircle. As it's an angle in a semicircle. Okay? So that angle here is 90 degrees. The sum of the two angles here will also be giving you 90 degrees. Angles in the triangle asked up to 180. So if C is angle here, you see, so angles subtended to circumference is 90 degrees. Then it means that this and this will give what? 90 degrees. That is why we are saying that the sum of A and B is 90 degrees. Okay? Note, there is not enough information here to work out A or B. You will only know that A and B will give you what? 90 degrees. But you will not be able to know that maybe A is 40 and B is 50, or A is 35 and B is 55. Like, you will not be able to identify because the information is not enough. But all that you know is that A and B, when sum them, you get 180 degrees. So that is what this preamble is saying. So you must need other information, one of these, to be able to find the other. Okay? Yes. Now, we want to look at the proof. The angle to the semicircle is always 90 degrees. We want to look at the proof. So please, if you like the video, make sure you subscribe and share to bless some other friends. Okay? Now, the proof says that if I have a circle, well, in a diameter, the circle has a triangle drawn inside it, where the circle has been split into two. So we split it into two by the diameter. Now, so imagine that we draw a line from the point of the triangle to the center. Imagine we draw a line here to the center. Okay? Draw a line here to the center. In effect, the radius, so it means that this counts a radius. Okay? The smaller triangle create is an isosceles triangle. You see that this angle here is an isosceles triangle because this angle, it's a radius, and this is also a radius. When two lines of a triangle are equal, then it forms an isosceles triangle. Likewise, this and this is also another isosceles triangle because it's a radius and it's also a radius. Look at it very carefully. This line here and this line are the same length. This line and this line are also the same length because from here to here it's a radius, and this is what? A radius. Let's keep going. The smaller triangles create an isosceles triangle because two sides are the same radius. So this angle here, this line and this line are equal. So if we label the angle x, so if we label here as x, here must also be what? X, because these angles are equal, because these lines are equal. Alright? So then the other angle is effectively 180 degrees minus 2x. This angle here. Because yes, x. Angles in a triangle sums up to 180 degrees. So x plus x will give 2x. Once you get this, you take 180 degrees minus 2x to get this angle. So it means that this angle here is 180 degrees minus 2x. Very simple, right? So when you sum everything inside here, you should get 180 degrees. That is, this plus this will be positive together. So subtract you get 180 degrees. You can do the same to the other side. So which means that this other angle here will do what? To work out the other angles on the straight line, you would do 180 degrees minus 180 degrees minus 2x. That is angles on a straight line. This one will give you 180. So if yes, 180 minus 2x, I will take this answer from 180. So 180 minus this will give you this angle here. Okay. And when you send the negative inside, you have this. This and this goes away. Remember, this place is 2x. This angle here is 2x. That also explains another theorem. Two opposite interior angles give you the sum of an exterior angle. The sum of two opposite interior angles give you one exterior angle. So 2x. Alright, so here is 2x. Well proved. Now, if that's the case, we can also say that apply the same logic to the other triangle. That is this angle. That is y, and here is also y. Yes, you can also do y. Look at the same theorems, same principle. Here also give you 2y. Okay? Let's keep going. So 2x plus 2y will give you 180 degrees straight angles. There's angles of a straight angle. When I sum these two, I'll give you 180 degrees because we are on a straight line. We are trying to prove why this is very good. Okay? I can factorize the 2 out. When I factorize out and divide 2, 90, and get 2 x and y. Which means that x plus y is what? 90 degrees. X plus y is what? 90 degrees. So we are saying that this angle here is 90 degrees. Look at the theorem here. Very simple. Now, we want to solve one more examples and then we're going to do example 3. Work out all the missing angles. Work out all the missing angles. So we have from A, B, C, D, E. And the A You know it, right? Yes, because these lines are all the radius, and they are equal, forming a straight triangle. If the two lines are equal, but the base angles are also equal, so it means that A is what? 50 degrees. Angles in a straight triangle. Then we get that to be 50 degrees. We also get B, angle B. So if here is 50, here is 50, you can guess here to what? 80. Because angles in the triangle sums up to 180 degrees. When we do the proof, we look at that. Here was XY. And you can take it out of 180 degrees. So that will give you 80 degrees. This plus will give you 100. 180 minus 100 is giving you 80 degrees. Now look at the angle C. Angle C. Angles on a straight line sums up to 180 degrees. When we do the proof, here was 2x and here was 2y. We sum them. You get? Yeah. So take 180 minus 80, and that will give you 100. Which also tells the theorem that two opposite interior angles give you one exterior. That if you pick on this triangle out, this exterior angle will give you the sum of these two opposite, not the adjacent, opposite. So this line must always give you this angle. And this line, this will give you this angle. I've already gone ahead of myself, you understand? So the angle here is 100 degrees. Now we know here to be 100 degrees, we can find this angle also, right? But look at the property here. This is subtending from diameter. So here angles what? 90 degrees. If this whole thing is 90 degrees and here is 50 degrees, here must be what? The D must be what? 40 degrees. Angles in the semicircle. Okay? Yeah. Then we continue. If here is 40 degrees, here must be what? 40 degrees. Because here is 100, this plus will give 180 degrees. So here is 40 plus 100 will be 140. Here, what we get? 40, so that you can get 180 degrees. So, and the E here is also 40 degrees. Angles to this associated triangle. Without working, you can also know that this line and this line, because this is radius and this is a radius, the base angles are equal. If this line is equal to this line, then the base angles are also equal. Okay? So you see that the theorems are very easy and very simple to understand. Once again, you can go to the comment section and leave your comment, and I will happily reply that. Don't forget to subscribe. Okay? So it means that the angle is also what? 40 degrees. Now, we highlight this to show the diameter. And it is from here that we apply all the theorems. So when you see the diameter, we apply all the theorems we are using. When it's not a diameter, then those theorems will not be able to apply. Perfect. Okay? So, example 4. Work out the two labeled angles and state reasons for your answer. So two labeled, so we have X and T. Work them out. Okay? This is a diameter. BC is a diameter. BC is a diameter. And this is what? A straight line. Angles on a straight line sums up to 180 degrees. So we can find angle X. So 180 minus, same the two, give me angle X, which is 108 degrees. Angles on a straight line sums up to 180. So simple as that. Now we can get the angle T. We can get the angle T. Alright? Which is on this place. But remember, this is a radius and this is also a radius. Which means that if I have this line being equal, then I can find my T. Triangle ABO. ABO is associated triangle because of the two lines being equal. and with the center as O. The two angles at the base will therefore be equal. So here, this angle and this angle are equal. So I can say that this is also T. If I say T plus 108 degree is equal to 180. Well, this and this are also equal. You can just take 180 minus this and divide that result by 2 to get 180. So 180 minus 108, that will give you 72. Divide that result by 2 and get 36 as T. Also, two opposite interior angles give one exterior. So here, the sum of these two angles will give you 72. That proves this. Okay? And when because there are 2 points, you must divide by 2 to get each of them. That's why we divide the 72 by 2. Divide the 72 by 2 to get 36. Remember, the degree is very important. Always write it. Don't write a degree on top of it, then you are not talking about and you are not talking about angles. So make sure you put it in. So here is 36. Now we want to look at the next theorem. Next theorem states that opposite angles in a cyclic quadrilateral is supplementary. Supplementary means they sum up to 180 degrees. They are supplementary means they sum up to 180 degrees. So when I have a circle, for example, and I have a quadrilateral drawn in it, two opposite, so this is the center, two opposite angles in a cyclic quadrilateral. It's a quadrilateral, a four-sided plane figure drawn in the circle. That's what we call it a cyclic quadrilateral. Cycle, and the quadrilateral inside. So this angle here and this angle will sum up to 180. This angle and this angle will sum up to 180. But we are saying that the opposite angles are summing up to 180 degrees. Okay? If I have another one here, and this is from the least one I've drawn, so we do that this angle here and this angle here will be equal. So I'll just label that A, B, C, D. So angle X and angle Y are what? Equal. So when we sum them, we get 180 degrees. When we sum this and this, it gives 180 degrees. So in case A is also B, you can go ahead to. So I'm just illustrating something here. So the opposite angles in a cyclic quadrilateral add up to 180 degrees. The same theorem, I still continue. The proof, what do you look at the proof? Why I would say that it's added to 180 degrees. So if I have a circle, and this is the center, and this is a quadrilateral drawn inside four-sided plane figure, drawn inside there. Imagine we join two corners to the center of the circle. So imagine I draw this to the center, two corners. If we label the top angle as x, the one at the center will be 2x. If I label here as x, here will be 2x. This angle here is half of the angle here, so here is x, here will be 2x. Now, do the same thing with the opposite angle, label it y. So, if I do the same thing here, this is y. The one at the center will therefore be 2y. Here also be what? 2y. The angle is also twice of this. It means that this 2y plus 2x will give you 360 degrees. Because a complete circle, angles in the circle sum up to 360 degrees. So here is 2x and this is 2y. When I sum them, it must give me 360 degrees. Okay? We continue. So it means that when I subtract the 2 out and divide it to, I'll get u divided by this will give you 180, and x plus y will also give you what? 180 degrees. Okay? That is the angle the theorem was made. Now the angles at the circumference is half the angles at the center. That's what we just used. The circle, the angle here is half, so it's twice the angle here. So if here is 50 degrees, then here will be 100 degrees. If here is 100 degrees, then here will be 50 degrees. I think we have looked at that in the previous example. No matter where it is subtending at in the circumference, it will always be 50. Once it is from here, it will give you 50. No matter where it is subtending, it will give you 1. Look at this, very small, but the angle here, if here is 50, here we got 30, because this angle is half of this, so here is twice of this. The same, if here is 30, here we got 50. This tells you that this angle here and this angle here must always be the same. Once they are subtending from the same chord. Okay? If I have another one, means that this angle here is twice of the angle here. So here is 130, here what? Divided by 2 gets 65. And here also be twice of an angle is subtending here. Okay? So you get that, here also be 115 degrees. Simple, right? We pick word example 4. Calculate angle A and B and give reasons for your answer. You are calculating A and B, but you should know that A is equal to B from the theorems we look at. But you must get one so that you can be able to get the other one. We say that this angle here is half of the angles at the center, because when you draw a chord here, they are from the same chord. That's where the theorem is coming from. So if here is 122, then A will be 1. A will be 61. So 122 divided by 2 gets 61. The angles at the edge, or certainly to the circumference, is half of the angle at the center. So here is the center. So we mean that the angle is 61 degrees. The same way to the B. This angle has just like the from the same thing. I just moved to this side. This angle here is so half of the angle here, which is 61 degrees. Same as above. Can you say this way?